Hello and welcome to Easy Maths. In this lesson, we're going to look at the application of matrices in solving simultaneous equations. And as always, please like, share, and subscribe to my channel. I'll appreciate your support. Let's turn now to the lesson, application of matrices in solving simultaneous equations. Now, as we begin, let me mention that matrices can be used to solve simultaneous equations. For instance, we have the simultaneous equations x plus y is equal to 5 and 3x minus 2y is equal to 0. We'd like to solve this one, only that we're going to have to use the knowledge of matrices. Now, as we do that, we're going to do the following. Number one, we form three matrices from the two equations that are given. The first matrix will be the matrix of the coefficients. The second matrix will be the matrix of the unknowns, and the last one will be the matrix of the answers that are given in the two equations. Again, we're going to use the knowledge of inverse and identity matrix, and of course also determinant in there, to solve the simultaneous equations. Only that we are going to use now another method, the method of matrices. It's assumed that at this point, students are already familiar with, I think, three methods of solving simultaneous equations. So this is going to be the fourth one, or just an additional method from to the ones that the students already know. Now the three matrices are these ones here. We have 1, 1, 3, minus 2. This is a matrix of the coefficients. The coefficients of x, y, 3x, and minus 2 are 1, 1, 3, and minus 2 respectively. The x, y are the unknowns in the two equations. And 5, 0, which is the last matrix, is the matrix of the answers. 5 and 0 are the answers that were given for the simultaneous equations. So now a student might wonder, why is this written? The reason is simple. And let me show you. If we multiply the matrix 1, 1, 3, minus 2 with x, y, we're going to get this particular matrix. 1x, 1y, 3x, minus 2y. I've written it that way for the sake of simplicity. We have 1 times x is 1x, although we can just call it x. 1 times y will be 1y, although we just call it y. We have again 3 times x, which is 3x, and we have minus 2 times y, which is minus 2y. And the 5, 0 is the answer. So the part before the equal sign, simplified, if you multiply these matrices together, you're going to get this particular matrix. And the way it appears here, the x, y, 3x minus 2y is the same way it appears here, only that we don't have the brackets. And therefore, that's the rationale. And we use that concept to help us in solving the simultaneous equations. So having formed these three matrices here, we need to determine the determinant of the coefficients matrix. Determinant of the coefficients matrix, which is going to be, in our case, 1 times minus 2, then minus 3 times 1, which gives us minus 5. This is negative 2 minus 5, minus 3 rather, giving us minus 5. The inverse is the reciprocal of that times the transposed matrix. We're going to change 1 and negative 2, so we have negative 2 and 1. Then 1 and 3, their signs are reversed to get negative 1, negative 3 respectively. And this particular part here, simplified, will give us this particular matrix, which is the inverse of the matrix 1, 1, 3, minus 2. With that, now we move to the part where we start to solve the simultaneous equations. And this is what we need to do. We pre-multiply this particular statement here. We pre-multiply it with this particular inverse as shown hereby. This is what we have. This particular part here is the inverse that we had. This 1, 1, 3, minus 2, and xy are the two matrices that we were having at this point. Again, this part, 2, 5, a fifth, 2 over 5, 1 over 5, 3 over 5, and negative a fifth here is still the inverse, and the 5, 0 is the matrix of the answers, that we're having at this particular point. So what we've done here is multiply before and after the equal sign, the two sides there, before and after the equal sign, to get this particular mathematical statement, which is mathematically not correct, not different from this one, because we have multiplied the same thing before and after the equal sign. With that, we move to the next stage where we multiply before the equal sign. We multiply the inverse of the matrix by the same matrix. And we have said in a previous lesson that that would always give us an identity matrix. This time around, we're going to get a matrix of 1, 0, 0, 1, a 2 by 2 matrix. We move ahead and multiply this identity matrix with the matrix of the unknowns, which is going to give us x, y. That means the identity matrix just goes away. And that tells you something. Before the equal sign, there really isn't any work to do. When a student gets to this particular stage, they just need to move straight to the coefficients x, sorry, not the coefficients, the unknowns x, y. The only work there is to do there is something that has to do with the matrices after the equal sign. And therefore, we now multiply these matrices, and the answer is simply going to be 2, 3. Please follow the procedure of multiplying matrices, which was also tackled earlier in this particular topic. This therefore tells us the answer for x is simply 2 and y is 3. And those are the answers for the set of simultaneous equations that were given. X plus y is equal to 5, 3x minus 2y is 0. And you can always verify that, even using another formula. Having said that, let me say some 3 points as we wind up the lesson. Number 1, if the determinant of the coefficients matrix is 0, if the determinant is 0, then that matrix has no inverse. If the matrix of the coefficients has a determinant that equals to 0, therefore that particular matrix doesn't have an inverse, and therefore that means that the simultaneous equations have no solutions. And there are two possibilities. Either the lines are parallel, two lines which are parallel do not intersect. That means there is no solution for that. Or the the solutions are infinitely many, or the lines are coincidental. And you shall see that in the next, actually the last lesson. So you can check out the next lesson after this, and then the last lesson, which is going to elaborate a lot more about what's happening with this last note here. And as always, please like, share, subscribe. I'd appreciate it. Thank you.